So in today's lesson, we are going to talk about right triangles and problem solving using those right triangles. By the end of the lesson, we are going to be able to find missing parts of right triangles and solve problems using right triangles. So if I look at my first example, I have a right triangle which has a hypotenuse of 100 and an angle 40 degrees, and the length of the leg opposite to the 40-degree angle is A. So I'm going to have to use a trigonometric ratio that is opposite over hypotenuse. So sine of 40 degrees and 0 minutes will equal to A over 100. And if I multiply both sides by 100, I will get 100 times the sine of 40 degrees will equal to A. And now all I have to do is punch this in my calculator. So sine of 40 degrees times 100, and that will give me 64.2788. So approximately A will be 64.2788. So I needed to round it to 4 digits, so that's why we had this answer. In the second example, a balloon pilot notes that she is directly above one of the goal lines of a 100-yard playing field. Using a sextant, she estimates that the angle formed by the first goal line, herself, and the second goal line measures 10 degrees. How high is the balloon? So you can see the diagram I created for this problem, and I need to use a trigonometric ratio that is involves an opposite to the angle and an adjacent side to the angle. So its tangent of 10 degrees will equal to 100 divided by A. And if I multiply both sides by A, I am going to get A times the tangent of 10 degrees equals 100. So if I divide both sides by the tangent of 10 degrees, then I'm going to get the answer for A. So A will be approximately 100 divided by the tangent of 10 degrees. So A will equal to approximately 567.13 yards. In our next problem, a forester stands 200 feet away from the base of a tree. Viewing the top of the tree, he estimates the angle of elevation to be 20 degrees. How far does the tree rise above eye level? So the first thing I'm going to say, if he stands on the left, his eye level is going to be approximately lined up with this line right here. And what I need to figure out is how far this tree rises above eye level. So I'm going to represent that x, that distance x. So again, I need to use a trigonometric ratio that involves opposite over adjacent. So I will have to use tangent of 20 degrees will equal to x over 200. And if I multiply both sides by 200, I am going to end up having 200 times the tangent of 20 degrees, which equals x. And if I punch this in my calculator, 200 times the tangent of 20 degrees, I will get 72.79 approximately. So x will be approximately 72.79 feet. In question number 4, we have a hiker that notices a spot at eye level on a trail ahead. The hiker counts her paces and finds that the distance to the spot is 50 feet. The hiker's eyes are 5 feet above ground. At what angle does the hill rise with respect to the horizontal? So again, I created a diagram already, and we need to use a trigonometric ratio, which will be sine of alpha, and that will equal to 5 over 50. So if I reduce the fraction, the sine of alpha will equal to 1/10. And I need to use the inverse sine, so I'm going to do the inverse sine of 0.1. So inverse sine of 0.1, and that will give me approximately 5.74. So alpha will be approximately 5.74 degrees. In example number 5, an airplane leaves an airport and, not at, but and, travels for 50 miles in a direction of 10 degrees east of north. How far north and how far east did the plane travel? So I represented the north distance by y and the east distance by x. So I will have to use more than one trigonometric ratio. So the first thing I'm going to do is use sine. So I'm going to use sine 10 degrees will equal to x over 50. And if I multiply both sides by 50, I am going to get sine 10 degrees multiplied by 50 is equal to x, and x will be approximately 50 times sine 10 degrees, which will be approximately 8.68. So the distance is about 8.68 miles, which is my x distance. Now I am going to find the distance y, which is the distance towards north. So I'm going to use cosine of 10 degrees will equal to y over 50. So 50 times the cosine of 10 degrees will equal to y. And if I punch this in my calculator, 50 times the cosine of 10 degrees, that will give me 49.24 miles. So y is approximately 49.24 miles.